Hi, seventh graders. Today we're going to extend our discussion on square roots from last week to cube roots today. And before we do, I want you to think about the difference between length, area, and volume. Okay? And I have three diagrams on this slide: a line, a square, and a cube. And length is a linear measurement. Length is from one point to another. It's a straight line. It's measured in simple inches, centimeters, or meters, or kilometers, or miles, or whatever. Okay? Area is two-dimensional, like covering a flat surface, like tiles on the floor, wallpaper on a wall, okay, a rug. Okay. Area represented by the square is measured in square units, square inches, square centimeters. And now remember, the shape doesn't need to be a square. The area of a circle is measured in square units. The area of a rectangle is measured in square units. The area of a triangle is measured in square units. Okay, but it's easiest to sort of represent with this square here. And then lastly, we have a cube. A cube is three-dimensional. When you're talking a cube, you're talking the space inside. Like, for example, last year we had to buy a refrigerator. And refrigerators, they talk about cubic feet in the refrigerator, how much space inside the refrigerator. Okay, an aquarium, how many gallons it can hold. Gallon is a three-dimensional unit. Gallon is a measure of space, not weight or anything, which is why a 20-gallon tank is twice as big as a 10-gallon tank, obviously. Okay, and it's measured in cubic unit, cubic inches, cubic centimeters, and things like that. Okay, and square numbers and cubic numbers are numbers that we give those special names to. Okay, there's no special names for numbers until fourth power, fifth power, sixth power. Just that. Again, as we discussed in class, because square numbers 9, 16, 25, 36, you can actually represent in the form of a square. Cubic numbers, you can actually represent in the form of a cube. For example, if you look at each of the corners of the square, there's 1, 2, 3, 4 in the front, 5, 6, 7, 8 on the back. 8 is a cubic number. 2 wide by 2 long by 2 high. 2 times 2 times 2 is 8. 8 is a cubic numbers. And cubic numbers you can represent as sort of corners on a square. So we're going to look briefly at some problems evaluating square roots and cubes. And I'm also going to have you watch another video about how to use that on the TI. Those of you who have the Casio, you may need to just look that up for yourself. But I know most of you have the TI, so that's the one I'm going to put on this. If I can find one for the Casio, I will add it to the later on. Okay, so first problem here says Matt and his dad are building a treehouse. They buy enough flooring material to cover an area of 36 square feet. What are all possible dimensions of the floor? Well, you actually can't list all possible dimensions of the floor. Because if you think about fractions and half units and half inches and things like that, there's an infinite number of possibilities. But if we're just going to stick with whole units, well, you could have a very narrow floor that's 1 foot wide by 36 feet across. And that would give you 36 feet. Okay. A little bit wider, you could have one that's 2 feet by 18 feet, 3 feet by 12 feet. Let's see, 4 feet by 9. 5 doesn't go into 36. 6 goes into 36. 6 times. And because I've now repeated a number and I started at 1, it's a logical matter, I now know those are all the possible dimensions if that floor is going to be in whole number units. Okay? And you'll notice that obviously the square, the only square number, well, the only square units there is 6 by 6. So if I wanted to make it a square floor, it'd be 6 by 6. Wanted odd dimensions, you could do something else, make it 9 by 4, depending on the space that they have. Okay. Now looking at a cube unit, you've got a birdhouse, and we're talking about the volume, the space inside. How much space do those birds have all around and inside that birdhouse? Okay, that's cubic units because volume is length times width times height. Now, without a calculator, finding a cube number is not that hard as long as it is a perfect cube. For example, I know 10 times 10 times 10 is 1,000. This is 216. It has to be less than 1,000. Okay. I also know it has to be an even number because an even number times an even number is even, an odd number times an odd number is odd. So I know it could be 8, it could be 6. I know it's not 4 because I know 4 times 4 is 16, and 16 times 4 is certainly not 216. It's actually 64. So that birdhouse is either 6 inches by 6 inches by 6 inches, or 8 inches by 8 inches by 8 inches, and we know that because it says it's cube shaped. Well, if we think about the units and multiplying, 8 times 8 is going to be a number ending in 4. A number ending in 4 times 8 is going to end in a 2, because 8 times 4 is 32. But 6 times 6 is 36, times 6 is 216. The length, width, and height of that birdhouse is 6 inches. Okay? So the cube root of 216 is 6 inches. And I'll show you what that looks like in just a moment. In fact, if we jump down to this page, okay, notice you have right here the little 3, what's called an index. That's the cube root of 64. What number times itself is 64? And as I mentioned just a moment ago, the number that times itself is 64 happens to be 4. That means 64 is a cube number. It's a perfect cube. 100, square root of 100, notice there's no index there. There's no index there, we're just talking the square number, is 10. Square root of 49 is 7. And the cube root of 8, which we've discussed before, is 2. Because 2 times 2 times 2 is 8. So finding these are not that difficult, especially if it is a cubic number. Okay, there's one other problem I want to look at. Here we go, using number sense. Okay, and let's talk about the cube roots. 1331. Okay, well, if we think about what we said a moment ago, 10 cubed is 10 times 10 times 10, which is 1,000. So I know it's got to be more than 1,000. I also know it needs to be even. Okay, so I'm going to just hang on for just a moment. Let me pause the video. Sorry for that brief pause. My granddaughter came to say goodnight to me. We had fun trick-or-treating. She was dressed up as Lilo, and the little baby, the youngest granddaughter, was dressed up as Stitch. My grandson happened to be Batman. Okay, so getting back to this problem. 10 cubed, so I know it's more than 10 cubed. And I know 20 times 20 is 400. And 400 times 20 is going to be 8,000.
Baby Guillermo went on the walk.
Okay. So I know it's got to be less than 20. So that leaves me with 11 cubed. 13 cubed. Didn't mean to hit that. 15 cubed. 17 cubed. And 19 cubed. Again, because I know, gonna hit the wrong button, sorry about that. Now 20 cubed, 20 times 20 is 400 times 20, 8,000. Okay, another thing I know it can't be 15 cubed. Because if I think about those, that number is going to end in a 5. A 5 times a 5 times a 5 is going to end in 5, so I know it's not going to be 15 cubed. Well, where'd that go? So it's not going to be that. So if I had my things, I could change the font. I'm going to do that right here. And where's my font? Strike through that. Now 1331 is a lot closer to 1,000 than is 8,000, so I think it's going to be on this end. And now I'm thinking again, my little number sense, thinking about ones place, because nothing comes on that one. 13 times 13 is going to end in a 9. And something times by ending in a 9 times 3 is going to end in 7, so I don't think it's my 13. I'm pretty sure it's going to be 11 cubed. And if I actually do it out, and I'm going to do my spot right now, but 11 times 11 times 11, indeed is 1331. The other number, 5,832, obviously that's going to be even because it ends in an even number. And it's probably going to be on the higher end. Now, I don't think that can be 16 because something ending in 6 always ends in 6. So 14, 4 times 4 is 8. 8 times 4 makes 32. So it could be 14. Could be 18. I don't know. But it's probably one of those two. So we can do that. Also, we can do this on a calculator. So I'm going to play a video now on YouTube. And this is how to find the roots using your TI-30, your square button, and the calculator button. So I'm just going to play this.
Hello and welcome to HP Calcs. I'm Rick, and today we're going to have a look at how to get roots on the Texas Instruments TI-30X2S calculator. Alright, to do this we're going to be using the x squared with the second function of square root key located here, the up arrow or caret key with the second function of the x root key located here, and obviously the second function key located here. Alright, to get started, if we want to simply find a square root of, let's say, 25, we would enter the second function of the x squared key. So we get the root symbol on the top there, enter the 25, and then press enter, and we see that the result of this is 5. The square root of 25 is 5. Alright, what about a cube root? What if we wanted to find the cube root of 1000? Well, to do this, first we enter the 3, then the second function x root key. Here we have the third root, and then enter the 1000 equals. This gives us 10. The cube root of 1000 is 10. Alright, what if we wanted to find a root that was a fraction? So let's say a half root of 2. Well,
Okay, I'm pausing the video there because you don't need to worry about finding a root that is a fraction. Okay? So your homework is on Savas Realize. And it is mainly about finding roots and square roots. And there are questions like this one here where it says, for example, cube root of 27. And there's somewhere it asks you whether or not a number is a perfect square, perfect cube, both, or neither. So 144. 144, I know it's a perfect square because 12 times 12 is 144. Now, is it a perfect cube? Well, I'd have to check that because then in that case, the answer might be C. And if it's neither, then the answer is going to be neither. Okay, so that's your homework for today. You can work on that as soon as this video is done. You probably will finish the homework in class. So then what you can do is go on IXL and work on your recommendations wall. Hope you have a good day. I will be back in school tomorrow. If you have any questions, please do send me an email. Okay, that is all. Thank you.